Hello everyone and welcome to this video. So in this video we'll be looking at the newly introduced OneLake table APIs for Delta tables that are created on the OneLake storages. So these APIs are a bit different compared to your standard Fabric REST APIs that you would normally use to query your underlying Fabric ecosystem. So one thing is that the operations to these APIs are compatible with the Unity Catalog API open standards, while your Fabric REST APIs are not. The major limitations of these standards are that the name of the underlying objects cannot have a special character in them. Say, for example, you have a workspace name or a lakehouse name that has a special character in it. For instance, a lakehouse having name concatenated with an underscore followed by, say, a date timestamp. So running operations on such objects are not supported through these APIs. So the way around is to replace the object names with the underlying object IDs, the example of which you can see on the screen. So there are three supported operations that you can run on the underlying objects through OneLake APIs. So they are the list schemas, the list tables, and get table. So list schemas get you the list of all the underlying schemas of a given lakehouse. Then you have the list table gets you the list of all the tables in that given schema. And then get table gets you the details of a given table. So like in get table, you can get the details of the columns, the type of the column, the name of the columns, the ordinal position of the column. Yeah, so I had written a blog. I mean, I had written an article more than a year ago that tried to get the same detailed information of the Delta tables through Parquet.net and ADLA Gen 2 API, similar to what Sandeep Pawar had got through the describe table and describe history commands. But in his approach, the information was fetched to the Spark environment, while with my approach, the same information could be obtained outside of the Spark environment. So as I said that I used Parquet.net library through which I was able to fetch the Parquet tables metadata. So Parquet.net is a open source library that requires .NET runtime and can run on any flavor of OS, and it supports read and write operations of the Parquet files. So this is the output that to get through my approach. All right, so the output was like at the first column you have the lakehouse name, then you have the table name, and next you have the number of columns for that given table, and then it fetches whether the V ordered is enabled for the given table, the number of files and total size of the files, and then it gets the row group details. For example, a row group count, then you have the total row group size, then the minimum row group size, and then the max and the average. Then also fetches the number of rows and the columns on which the table is partitioned and Z ordered by, and it fetches the optimized operation details like number of optimized operations that were executed on the table, and what was the last time when it was executed, and also it gets the write operation details like number of write operations and the last write operation date time. One thing that if you have noticed, so here if you look here, the the year values are a bit weird. So like every year value has a 0001 value. So this is because the date time values are stored in Unix epoch in the delta log table. So what I had to do was that I had to use an custom function to convert the Unix epoch values to the equivalent date time values. So this is the function, and this is the output of that function. So now you can see that the function outputs the changes the those weird date time values to the equivalent date time values. I mean, sorry, converts the weird year values to the equivalent year values. So I was expecting um, more or less output from this OneLake table APIs, but unfortunately the outputs are a bit limited. For example, but one advantage of this is that you can get the column level details of the tables. But with my approach, that was not possible. You can get the creation date time and the users details who created those columns. You can get those details for the given table like here. Okay, so I'll be running this code. So I have this code here that I've created, and so I'll be using this workspace. The workspace is my underscore workspace. So as you can see, there's a special character in the name, and also there's a special character in the lakehouse underscore one. So what I'll have to do is that I'll have to fetch the equivalent workspace ID through Fabric REST APIs for the workspace, and once I have the workspace ID, then using that I'll have to fetch the works the lakehouse ID for this workspace lakehouse underscore one. Okay, so I'll be using the Entra ID, my Entra ID through a service principal. So I've created this service principal, OneLake API, and the API permissions. Yeah, the API permissions are that it needs an delegated permissions for the storage dot Azure storage scope. So they mentioned it here somewhere. Okay, so it needs the API permission for Azure storage, storage.azure.com. So for my this OneLake API service principal, I have already granted that. So here I have like user impersonation for Azure storage, and after that I have these permissions for fetching the lakehouse ID and the workspace ID. Okay, so let's get started with the code. So the first thing is that I have to this is the app settings.json from where it will pick up the client ID, the workspace name, and the lakehouse name. This works client ID is the client ID of the service principal, and then this is the CSV location where the details would be exported to. So this is the CSV location, and this is the workspace name and the lakehouse name. That is lakehouse underscore one, and workspace is my underscore workspace. So I'll have to check this client ID is correct or is it the same. Okay, it's a different client ID. Okay, I'll copy this. Okay, so this is the code. So if you look here, I'm not using any Parquet.net library. So this is purely through the OneLake API. So at the entry point of this application is the read config that reads the data through reads the settings from the app settings to the configuration builder, and I can just I'll just start executing the code. Okay. So this is the first call to the workspace API, Fabric REST workspace API, to get the Fabric ID to fetch the workspace ID. Unsure what happened here. Okay, so I'll just debug the code. So for creating the access token, I've used the MSCL library. So I'll have to provide my user ID details to create the access token. So it's gonna impersonate my user credentials to fetch the details from the authentication is completed. And if you look at the response here, so I have the response. Sorry, so I have the details of the workspace. So these are the workspaces. So these are the workspaces in my Fabric tenant. And another thing I wanted to highlight was that I'm using the spectrator.console. So this is a kind of a third-party library that helps you give more fancy outputs into your console application. So I'll just show that. So I'm not more client. So now it's saying that fetching workspace ID for, if you look at the output, so it's fetching workspace ID. Please wait. Put a slab. And also I'm using Newtonsoft library to pass the JSON values because I didn't wanted to use text serialization, JSON serialization, inbuilt C# JSON serialization, because then I'll have to create all those underlying classes for or to pass those JSONs if I had used those JSON serialization library. So this is parsing. So what it does here is that it checks whether the workspace name matches to the output of this, matches the output of the workspace name value that you have here. For example, this name, these are the workspace name that I have on my Fabric tenant. And once it matches it, it breaks from this for loop. So I'll just put the control here. So now I have the workspace ID, which is this. Now that I have the workspace ID, I'll move on to fetching of the lakehouse ID. Look at the output here. So the workspace ID for my workspace is this. Now fetching the lakehouse ID for lakehouse underscore one. So it has all the details for the given of all the lakehouse under that workspace ID underscore one. Sorry, my workspace. So this is the response. So this has the list of all of the lake houses, workspace, my workspace, and then again the same logic here. If this value from this j object matches to this lakehouse value that is stored in the app settings, so it will just break from this loop. I can just put it here. So now you have the lakehouse ID, and now also you have the workspace ID. So now that we have that, so we'll just, so my endpoint will be this, the base URL, that is onelake dot table dot fabric dot microsoft dot com slash delta, and I have the workspace ID. And as I said, since I have a special character in my lakehouse name, so I'll have to use the ID here. So this will be the ID, and then it's the ID, and this is the rest of uh, the endpoint URL. And again, here also I'll have to use the ID, which is this. So this is going to be my endpoint. Yes, so this is the catalog name, and this is the endpoint. So now it will start fetching. So now it will get the response of all the schemas that exist in this endpoint, exist in that lake house. So this here you have the schemas that exist, which is DBO. So if you don't have like if you uh, like the by default any lake house defaults to DBO schema. So I'll just like push this. Now once I have the schemas, now I can go ahead and fetch the tables, list of tables from that given schema. So this is going to be my endpoint, one lake table catalog name, and the schema name is DBO. I'll show that to you. This is the endpoint. Close this. Now this is going to fetch the list of all the tables in that given schema. So I have like three tables, I guess. So I have this one, sorry, medallion data, and LK table underscore one, LK table underscore two. So these are the three tables. LK underscore table underscore one, two, and medallion data. Yeah, one thing I also wanted to highlight was that it's okay if you have special characters in the table name, so that is acceptable. But the workspace ID, this first endpoints, the first endpoint, that is the list table and the list schemas, they don't accept special characters in the underlying object names. So here also, if you see, it's accepting the special character, this endpoint, get table endpoint. So we can move ahead. So now I have the table. So what it's going to do is that it's just going to loop through every table and get the uh, column details for each table in that in that response. So first thing is going to get is the medallion data columns. So this is my endpoint, which is the get table details. Get table. Oh, sorry. Yeah, get table. And the response is the list of all the columns in that given table. So I have customer name, customer email, customer region, region, product name, category, and so on and so forth. Yeah, so it's going to export it to a. So the first thing it's going to export is the export the table details like these metadata, the table metadata like the name, column, the source data source format, and the ID, storage location, the user creation details. And then yeah, one more thing I wanted to highlight was this. So these API list table, it doesn't get the same details as the get table for a table. Like here you don't see that created by details for through this list table endpoint, but you have those details through this um, get table endpoint. So these values are missing for this list tables endpoint. All right, so I have the output. I'll just quickly show that. Okay, it's not it. Okay, so this is gonna write the table details output first. So it's, yeah, so it's gonna write the table details output for the table medallion data. So it has a table ID, table name, source format, location, and created and updated. Again, as I said, that the output from this from these API methods for the user creation and updation date values is always in the Unix epoch time format. So you have to be careful like how you parse these values. So now these values exported. Now it's gonna export the column values for medallion underscore data table. So and the details of each step is like is shown through this spectral console output. So like processing table medallion data, table plus company exporting the medal of the schema to location. Now it's gonna process the column values, column details. So this is gonna create a different file, separate file, and then you should have the column details for my underscore person underscore medallion data. So this is the first column, customer name, because it's running through an iteration. So in the first iteration is gonna give the first column values, the second iteration, the second column values. Show bundles. Customer name, custom email. All right, so that's about it. I'll just finish this iteration. So I just hope you understood the process that I've used to get the details through those APIs. And I'll just run this, like I'll just run this. So let's see. So it has all the details as processing LK underscore table. So the process is completed, export completed, and CSV generated on this location. So I have three files for every table for the column details. You have the ordinal position and the name, precision, type scales. And then here you have the table details for all the table that exists for the given lakehouse. I mean, I can make this, I can change this code to loop through every lakehouse in a given workspace. Like instead of going through each and every lakehouse, I can just like put in the workspace and I can just say that iterate to every lakehouse and export the relevant details. Even that is possible. And another thing is that I can merge these two operations. Like I can merge the operations, the output from these operations with the output from the OneLake table API operations and merge into one single output. So that is work in progress. So I'll have that ready in a couple of days and I'll post the update for it. All right, then that's about it. I hope you understood the process and the approach that was used to fetch the lakehouse table and the column tables details, and also it made you aware of the limitations of using this approach. Okay. All right. Thank you very much.